1.3 Using angle relationships to find angle measures. In this lesson, we will use the angle relationships we learned about in 1.2 to find missing measures. Let's look at number 1. We have a pair of angles here, and they are opposite angles of intersecting lines, which makes them vertical angles. Hopefully, you remember that vertical angles are congruent. So x is equal to 112. Number 2. In this example, we have a pair of angles whose sum is 90 degrees. This makes them complementary. Again, complementary is two angles whose sum is 90 degrees. So x plus 68 is equal to 90 degrees. And now we're going to solve. Subtract 68 from both sides. X is equal to 22. Please pause the video and attempt number 3, number 4, and number 5. Number 3. You should have gotten the answer x is equal to 56. This is an example of a linear pair. In a linear pair, the sum of the two angles is equal to 180 degrees. So x plus 124 equals 180. Now we're going to solve. Minus 124 minus 124, which is how we get the answer 56. Question number 4 is a combination of question 1 and question 3. Because these are vertical angles, if this angle is equal to 43 degrees, y is also equal to 43 degrees. And here we have a linear pair. So 180 subtract 43, as we did in the previous example, 137. And I could use the same method to find angle Z, or use the fact that these two are vertical angles. So 137, 137. Question 5 is a combination of questions 1, 2, and 3. Y is a vertical angle to 72 degrees, 72. These two angles are complementary. So 90 minus 72 is equal to 18. Angle X and 72 form a linear pair. So 180 minus 72 is equal to 108. Number 6. Angle 1 and angle 2 are vertical angles. If the measure of angle 2 is 105 degrees, find the measure of angle 1. Vertical angles are congruent, so 105 degrees. Number 7. Angle A and angle B are complementary angles. If the measure of angle A is 42 degrees, find the measure of angle B. Because we will be doing problems that include algebra later, it's a good idea to set up a relationship statement and then substitute in the known values. These angles are complementary, which means they have a sum of 90 degrees. So angle A plus angle B equals 90 degrees. So now I can substitute in for my known value. Angle A is equal to 42 degrees plus angle B equals 90 degrees. Subtract 42 from both sides. Angle B is equal to 48 degrees. Let's look at number 8. Angle P and angle Q are supplementary angles. If the measure of angle Q is 64 degrees, find the measure of angle P. So once again, I'm going to write a relationship statement. Because angle P and angle Q are supplementary, they have a sum of 180 degrees. Angle P plus angle Q equals 180 degrees. We don't know the measure of angle P. plus 64 substitute for angle Q is equal to 180 degrees. Subtract 64 from both sides of the equal sign. Angle P is equal to 116 degrees. I mentioned that example 3 was a linear pair. Please use that information and pause the video to answer question number 9. Number 9. Angle 1 and angle 2 form a linear pair. If the measure of angle 1 is 113 degrees, find the measure of angle 2. Because they form a linear pair, they are supplementary. Angle 1 plus angle 2 is equal to 180 degrees. Angle 1 is 113 degrees plus the measure of angle 2 equals 180, and solve. Subtract 113 from both sides of the equal sign, and the measure of angle 2 is equal to 67 degrees. Now time to use some algebra. This is where setting up those relationship statements would be so much easier. If the measure of angle PQT equals 3x plus 47, so here we have PQT. It's going to be equal to 3x plus 47. And the measure of SQR is equal to 6x minus 25. So SQR 6x minus 25. Here we have a pair of vertical angles, and we know that vertical angles are congruent. So the measure of PQT is equal to the measure of SQR. Now let's substitute our known expressions. PQT would be 3x plus 47. SQR is 6x minus 25. We're going to start by moving our terms to one side. So we have subtract 3x, subtract 3x. That leaves us with 47. And 6x minus 3x is 3x. And minus 25. We're going to add 25 to both sides. 72 is equal to 3x. Divide by 3 on both sides. And 24 is equal to x. The question asks us to find the measure of SQR. Here we only have the value of x. So we need to substitute 24 back in for x for the expression of SQR. So 6 times 24 minus 25 to find our answer. SQR is equal to 119 degrees. The most common problem in using algebra and finding missing measures of angles is students often want to put any expression equal to another given expression. And it's really important that you pay attention to the given angle relationships. So let's take a look at number 11. So in number 11, we have AB is perpendicular to CD. This little symbol here, the upside down T, that represents perpendicular. When you have perpendicular lines, they create a 90-degree angle. The measure of DCE is equal to 7x plus 2. The measure of ECB is equal to x plus 8. In this example, we have a pair of complementary angles, which means the sum of their measures is equal to 90 degrees. So, angle DCE plus angle ECB equals 90 degrees. Now you can substitute in the known expressions. 7x plus 2 plus x plus 8 equals 90 degrees. Combine like terms and solve. Subtract 10 both sides. 8x equals 80. Divide by 8. and x equals 10. Substitute 10 back into our needed angle, which is DCE. So 7 times 10 plus 2. Please pause the video and attempt number 12. The answer you should get is 131 degrees. This time you have a supplementary relationship. So the measure of KNM plus the measure of MNJ is equal to 180 degrees. Substitute 8x minus 5 plus 4x minus 19 equals 180. Combine like terms. And solve. Add 24 to both sides. 12x is equal to 204. Divide by 12. Divide by 12. X equals 17. You need to find the measure of angle KNM. You're going to substitute 17 for x. So 8 times 17 minus 5 is equal to 131 degrees. This concludes the notes for 1.3.